Hello everyone, my name is Xinghao from Xinjiang University, China. Today is my great honor to give this presentation about my paper named Sound Event Localization and Detection based on adaptive hybrid convolution and multi-scale feature extractor. I will introduce my work from the following four aspects. First, introduction. Sound event localization and detection, SELD, refers to the problem of identifying the presence of identity independence or temporarily overlapped sound source, correctly identifying to which sound class it belongs and estimating their spatial directions while they are active. In realistic aero environments, there are numerous cooperating different sounds emitted from the sources distributed in space. Even humans cannot all directly identify and located multiple sources of sound, so it is very challenging for mechanics. To solve the SELD problem, two key issues denoted as sound events detection, SED, and sound source localization, SSL, have to be addressed. Common methods for SED task and SSL task are in there. In this paper, we use CNN to deal with SELD problem. Next, we will introduce the proposed method. The network diagram is illustrated in this figure. For the multi-channel audio, the log-mean spectrogram and sound intensity vector are extracted as the input feature of the network. The input feature first undergoes the multi-scale feature extractor and then follows the 5 AH count blocks and 5 average polling layer. Bidirectional gated recurrent unit is used to learn the temporary context information. This is followed by fully connected layers. We adopt the ACC DOA output, which unifies the SED and SSL losses into a single homogeneous regression loss. As shown in this picture, we proposed a multi-scale feature extractor that has multiple dilated factors within a single layer. The output of each dilated layer is fed into an adaptive attention block, and the feature map of each layer are concatenated together, and the dotted box indicates the concatenate operation. Here, a parallel structure is composed of a filter size of 1 times 3 and 1 times 5 for time frames, and a filter size of 3 times 1 and 5 times 1 for frequency bin. Then the feature map concatenated along the channel dimension and undergo an adaptive attention block to select the feature adaptive according to the importance. The output of adaptive attention module will be fed into 4 asymmetric convolutions and 1 adaptive convolution again. And the importance of features will be marked more accurately. Finally, in order to prevent the original feature information, we will add the original input to recalibrate the output. In this picture, the parallel structure is implied in adaptive attention block, which adaptively mitigate inference between the channel-wise and time frequencies-wise by exploring 2 different branches. The depth-wise separable convolution can not only adaptively capture the effectiveness of each channels, but also reduce the number of operational parameters. Then we will analyze the experimental results. In table 1, we have explored many combinations of asymmetric convolution. The effort is best when the combination of asymmetric convolution are 1 1 times 5, 1 times 3, 3 times 1, and 5 times 1. In addition, we also add adaptive attention block to the experiment. The experimental combination of same kind of hybrid convolution shows that the performance can be improved by adding the adaptive convolution. In Table 2, the first row denotes the scores of DCASE 2021 challenging task 3 baseline method. The second row denotes the score of the baseline method that adding the multi-scale feature extractor. The last row denotes adding multi-scale feature extractor and the AH-Conv. These results verify the effectiveness of the multi-scale feature extractor and the AH-Conv. In addition, we also explore the effectiveness comparison of convolutional two-dimension convolution and the depth-wise convolution in the adaptive attention block. Comparing two adaptive methods, the results shows that depth-wise separable convolution perform better. Finally, we introduce the conclusion. In this paper, we proposed a SERD method based on adaptive hybrid convolution and the multi-scale feature extractor. AH-Conv is designed to capture the time and frequency dependence. Multi-scale feature extractor is designed to extract the multi-scale feature maps. We also propose an adaptive attention block embodied in AH-Conv and multi-scale feature extractor. Through a series of ablation experiments on the development dataset, we verified the effectiveness of AH-Conv and multi-scale feature extractor, respectively. The results also shows that our proposed methods outperform the baseline methods on 4 evaluation metrics. Next, we will introduce state augmentation methods to improve the performance of our proposed methods. Thank you for listening.